Hi everybody, today I would like to share my research under the title, The Potential of Spatial Reasoning in Mediating Mathematical Understanding. So this research ideas stress the importance of spatial reasoning in the process of constructing mathematical understanding. So we're going to look at these ideas through the case of number line. But before that, we're going to define what we mean by spatial reasoning in this study. So spatial reasoning is the mental ability to deal with space-related informations. This ability can be classified into three skills. The first one is spatial imagination. It is the ability to see what is said. For example, when you read or someone telling you about the description of a location or place, then you have a mental imagination or visualization about the place or the location. Then, in that case, you use spatial reasoning. You need to use spatial reasoning to be able to visualize the locations in your mind. The second skill is spatial interpretation, is the ability to see what is drawn. One good example for this case is when you are given a math, and to be able to read the math, you will utilize your spatial reasoning, so that you can navigate yourself where you are on the math and how the math can be used to guide you during the journey. The third skill related to spatial reasoning is spatial representation. It is the ability to draw what is seen or said. For example, when you are given non-spatial information, such as numeric information, and then you can re-represent the information into visual forms, such as graph or bar or chart. In that situation, you need to utilize your spatial reasoning in order to be able to present the information into spatial form. Spatial reasoning has a strong connection to mathematical capacity or mathematical performance. My study shows that spatial reasoning skill, our ability in spatial reasoning, can be used to predict our mathematical performance. It states that the highest person's spatial reasoning, the better they will have a mathematical performance. It also identified that spatial reasoning support the constructions of mathematical knowledge through the embodied experiences. What is embodied experiences? Embodied experiences is based on the idea of embodied cognition, in which that in the process of constructing knowledge, we use our body capacity as a means to process informations. Our body capacity is including the sensory and motoric capacities. When we utilize these capacities, it requires us to use our spatial reasoning. Therefore, in the process of the embodied experiences, spatial reasoning play a crucial role. And let's talk about how spatial reasoning promote mathematical understanding. Let's see the example of 24 minus 18. If this problem is presented only like this on numerical representations, a student will have a number of challenges. First, they will have difficulties in understanding what is meant by subtractions. What is the solution for 24 minus 18? And how to find the solutions of 24 minus 18. And I'm going to show you if this problem is presented in spatial ways, which is then requires spatial reasoning, then the student will have opportunity or will be able to develop their own way of thinking to find the meaning of this problem. For example, when we present the problem on the number line, then the student will understand that 24 minus 18 is actually finding the distance between 18 and 24, or finding the length of the line segment between 18 and 24. And this will give them definitions about subtraction. So subtracting 24 minus by 18 means finding what is the distance between 24 and 18, and or the distance or the difference between 24 and 18. So to find the difference, the number line suggests students to think of adding number on 18, such as that reaching 24, or removing number from 24, such that it reached to 18. So the spatial representation of the problem here suggests students to find at least two ways of strategies in solving 24 minus 18. Either adding number on 18 to reach 24, or removing number from 24 to reach 18. So this spatial representation suggests students of way of thinking how to dealing with this problem. And this process what we call as spatialized instrumentations, in which that the spatial representation of the problem helps students in gaining understanding, in making meaning of the mathematical ideas. So from the example, we found that spatial reasoning has a potential to support students in constructing mathematical understanding through the use of spatial tools. We call this process as spatialized instrumentations. In the spatialized instrumentation, there is strong connection between our thinking, our body, and the tools. When the tools are presented in a spatial way, it will trigger our body to utilize the spatial informations of the tools, and in which that this information then transfer to our understanding, to our knowledge, to our mind, which is our mind that process the information spatially, and the spatial information then our mind then react to the spatial information in form of action. So then there is a loop between perception supplied by the spatial tool and action supplied by our mind. The loop between the spatial tool and mind underline the process of knowledge constructions. Thank you.